So there are two types of machine learning or supervised machine learning per se. And we said that one is classification and other is regression, right? Now, as I always say, always look at the root word, right? So what is the root word in classification? The root word in classification is classify, right? Now you may ask, what does classify mean? So classify means to arrange a group of people or things in classes or categories. It's as simple as that. All you are doing is you have got a lot of things and you are just grouping them. Like if I take a perfect example, here you can say I have a brinjal, I have a broccoli, I have a carrot, right? I have some burgers and all, right? So you want to categorize them. So we just pass this through the classification model or a machine learning model, and it is able to classify that, okay, all these fall under the category of vegetables and this falls under the category of groceries, right? So just think about it. If a company wants to do some analytics and they want to see how much stuff the customers are buying, and they want to categorize how much vegetables people are buying, how much groceries they are buying. So this is what we call classification, okay? So if we go with the definition of it, a classification involves assigning category labels to the new observations based on the past observations and labels. Now remember, as I told you, that you have got labeled data, right? This is a labeled data. That's why we are learning supervised machine learning. But the aim of supervised machine learning classification is to assign category labels. And anyways, you know about those category labels when we are actually, say, inputting your data, right? The classification can be binary. Binary, as we know, 0, 1s. So we are talking about two classes. Like here, you can say whether an email is spam or it's a ham. So not spam is also known as ham. And this is a perfect example. Let's say a lot of emails are being fed to the classifier. Now this classifier, based on its features, its machine learning algorithm is able to identify which one is a ham and which one is a spam, right? And based on that, it will send either to the inbox or it would send it to the spam folder. So simple. Either you can have binary, two classes, or you can go with multi-class as well. Multi-class could be that I'm trying to classify the types of fruits. So there could be multiple types of fruits and I'm just classifying based on that, right? So the common algorithms that we deploy with machine learning classification are decision tree, random forests, logistic regression, support vector machines, and neural networks. So don't worry about it, just the names that you should be aware of. And feature selection, right? So choosing the right features or inputs is critical for building an effective classification model. So it's very important that you know the features, right? So based on the features, only you would be able to identify or classify a model. It's a very good example here. We have taken about machine learning used in the healthcare sector. Like if you have to detect for the prostate cancer, right, you would be feeding a lot of images, right? And when it goes via the feature design, the MRI prostate image does contain a lesion or it doesn't contain a lesion. So lesion means whether that area is damaged or it is having injury, or it could be something like it's having cancer, right? So all we are saying, it is passed via the feature design, and based on that, it is able to identify or classify whether this category, this falls in the prostate cancer category or it falls under a different category, right? So just imagine if a person had to look at those images. Now a machine is looking into those thousands of images and giving the results, right? So choosing the right features is critical for building an effective classification model. So because here we are talking about healthcare sector, if you're not going with the right features, then maybe you could miss something. A person having cancer, and you might say, oh, it doesn't have cancer. So you need to be very careful in choosing your features. And yes, this is a supervised machine learning. So we are using labeled data. Remember, as we did with Setosa flour, it is a labeled data that you are giving. So it requires a labeled data set where each instance is tagged with correct class for training, right? So here, when you're feeding the data, you're already telling whether this belongs to this category or not. And this is your training data. And when the test data comes, just based on the test data, the machine learning algorithm should be able to identify in which category does it fall, right? Perfect. So then we talk about overfitting and underfitting. So what is overfitting? So we normally call it's an undesirable machine learning behavior, and it can occur when the machine learning model gives accurate predictions, because your aim is getting accurate predictions, but this happens only for training data and not for the new data, right? Or the test data. So that's why we call it overfitting. So balancing the complexity of the model to prevent overfitting or underfitting is very important. So what it says is that your model you really need to tweak your model. So this is where testing comes into picture. So based on this, you need to balance the overfitting and underfitting as well, right? So how the model performs with the say the testing data should be similar to how it performs with the training data. Okay, so now there are various applications as we discussed. Email spam detection is one of them. Then image recognition, as you can see, this is a perfect example of image recognition. So I am, let's say, feeding in a lot of say images, MRI prostate images, and based on that it's able to detect whether it's cancer or not. Medical diagnosis, as we discussed, and sentiment analysis as well. And it's even quite useful in real-time decision making, and in banking it can be used with fraud detection. So let's say there is a transaction A, transaction B, and based on, or there are multiple transactions, then based on the behavior or the features, it's able to identify whether I should put it in a fraud category or I should put in a normal category. Again, a good example of machine learning using classification. So with this, we come to the end of the lecture. Remember, what we learned in this lecture is supervised machine learning classification. Very simple. You are just classifying, or you are just adding category labels. Classify, as I said, arranging a group of people or things in classes or categories. Thanks for watching.